I'd like to show you a quick review of volumes by rotation. So we're going to find the volume of the solid formed when the area in the first quadrant, so just the first quadrant, bounded by y is x squared plus 1 and y is 5, is rotated around y is negative 1. So let's draw that in there. Y is negative 1. That's a horizontal line. Here we go. Right here. That's our axis of revolution. Okay, so we're revolving around something that is not bordering the solid. So as this gets revolved around, there's going to be a big old hole in the middle. And when you have a hole in the middle, that's the washer method. You're going to do the big radius squared minus the little radius squared. So let's draw in those radii. We have from the axis of revolution to the closer function. That's how we measure the radius. Axis of revolution to the closer function. The radius of the hole is your little r. Little r. So our little r here is top minus bottom is how we'll find the length of that. Okay, so going from there, the top is this curve. So that's x squared plus 1. And the bottom is negative 1. So I'm going to subtract the bottom, giving us a little r of x squared plus 2. Okay, from the axis of revolution to the farther function, that's the big R. So big R here is top minus bottom to get the length of big R. And on top is always that 5. So top is 5. And the bottom is negative 1 again. So I'm subtracting off the bottom, giving a big R value of 6. So big R is always 6, because that's a constant. But the little r will change at each x value, because it'll change the way that function changes. Okay, so let's set this up. I'm going to be integrating pi r squared, but we're going to be doing big R squared minus little r squared, so we can subtract out the volume of the whole. So I've got a pi integrating big R, which is 6, squared minus little r, which is x squared plus 2, squared, and this is with respect to x. I need limits of integration. X is the variable in here. We're integrating with respect to x. I'm going to use the x values for my limits of integration. X is starting at 0 and ending at 2. That's where these intersect right here. And you can find that by taking your x squared plus 1 and setting it equal to 5. If I want to know where those two functions intersect, I'll set those two functions equal, get x squared is 4, and that gives us positive and negative 2 for x, but we're only dealing with first quadrant, so we only need the positive 2. We're going from 0 to 2. I'm going to integrate that with my calculator, and I already did it. I got out 147.445. Please always go to 3 decimal places. Oh, thank you, sweetie. Okay, that was my kiddo. So what if we take the same area and rotate it around axis 3 instead? What if we do that? Let's see what happens. Okay, I'm going to erase, and we'll take a look at that. Okay. Maybe I'll draw this again. So let's try rotating around axis 3. So what happens if we're rotating around a vertical axis instead? Let's draw that same area that we had. 1, 2, 3, 4, 5. We had the parabola. We had the constant at 5. We're dealing with this area in here. Yeah? Okay. Let's see, where does this intersect? At 2, here's 1, here's 0. Okay, this is 1. And we're going to axis 3. So here's axis 3. Let's draw the axis of revolution. That's our axis of revolution. It's what it's going to revolve around. So this time, if I'm going to rotate around axis 3, I'm going to be measuring big R and little r from that axis of revolution. So from the axis of revolution to the closer function for little r, from the axis of revolution all the way to the edge there for big R. That edge is the axis. Okay, so big R is kind of nice. And remember that you measure from the axis of revolution to the farther function. Okay, big R, because I can't do top minus bottom here, I'm going to do right minus left. The right is 3, right minus left, that left is 0. That's x is 0. So big R is always 3. Okay, little r. The right is 3 minus, now this left function, watch out for this. I'm revolving around something vertical. It's vertical like the y-axis is vertical. Y is going to be my variable. I need to rearrange this y is x squared plus 1. Okay, so if y is x squared plus 1, I'm going to subtract 1. Y minus 1 is x squared, and then I can square root both sides. So I'm going to get positive or negative. The square root of y minus 1 is x. Now looking at this, since we're only doing the first quadrant, we're only dealing with the positive version of that radical. The negative version of the radical would be the part of the parabola that's on the other side. So I'm going to do 3 minus, and then this function, 3 minus that parabola. And so that's subtracting the root of y minus 1. That's little r. It's a little more complicated. Okay, but let's set this up. We've got pi. We've got an integral. I'm going to take the big R, which is 3, and square it. I'm going to subtract, and I'm going to take the little r, 3 minus root y minus 1, square that also. Y is our variable. We're going to integrate with respect to y. And I need limits of integration. Those limits of integration have to be y values to go with this. So let's take a look at what the y values are. The y values start at 1. That's where the area starts. And they go all the way until y is 5. So we're integrating from 1 to 5 for the y values. Math 9 on your calculator makes this beautiful and delightful. I got 75.398. Okay. Oh, good stuff. So we did volumes when we revolve around something horizontal. If you revolve around something horizontal, x is your variable. You're doing top minus bottom. But then also volumes if you revolve around something vertical. And if you're revolving around something vertical, y is your variable. You're doing right minus left. Have a lovely day.